shooting in excess of 20 billion stars ate up by probably the biggest dark openings at any point found in logical history is very difficult. Black holes have captivated astronomers and astrophysicists as much as any other cosmic mystery. The James Webb Space Telescope was used by astronomers to make a significant discovery that will alter our understanding of the size and scope of black holes. The object in question may weigh between 2 and 4 million times the mass of the Sun. What did they discover, and how much do we now know about these strange voids? Join us as we embark on a journey through space. The mass of these black holes, which were only discovered a few weeks ago, leads us to believe that they are quasar remnants. We should start with an outline of dark openings prior to plunging into the disclosures made conceivable by James Webb's cutting-edge hardware and logical undertakings. A lot of issue are brought into a very minimized space by dark openings, inestimable substances known for serious areas of strength for them fascination. Because black holes resemble ominous voids in the fabric of the universe, even light cannot escape their gravitational pull, which is why this phenomenon is sometimes referred to as a gravity well. Smaller black holes are found all over the universe and typically form from the ashes of massive dying stars. Interestingly, supermassive dark openings, which have cosmic masses between 1 million and 1 billion times that of the Sun, rule the focal point of practically all immense systems. The origins of supermassive black holes remain a mystery despite decades of research. These giants, which dominate the centers of galaxies all over the universe, fascinate scientists, but they struggle to comprehend the processes that led to their formation. However, more and more of the truth is being revealed to humanity by the most recent findings. In fact, Earth is actually circling a black hole in Sagittarius that is between 2 and 4 million times larger than our Sun. The discovery of a massive black hole with a mass roughly 9 million times that of the Sun thrilled scientists. This unbelievable finding was made conceivable by the James Webb Space Telescope, which found this massive item settled at the center of a world only 570 million years after the enormous detonation. Past its undeniable size, this revelation is critical in light of the fact that it gives new bits of knowledge into the beginnings of these grandiose monsters. Researchers accept that further discoveries of this sort will before long become visible, assisting with settling the riddle of the early development of these enormous substances in astronomical history. Throughout the long term, numerous revelations have been made. Supermassive dark openings and heavenly mass dark openings are the two sorts of dark openings researchers have found. Star mass black holes, whose masses typically range from 5 to 10 times those of the Sun, are thought to form when massive stars die catastrophically. These stars experience a gravitational breakdown that finishes in a cosmic explosion blast when their atomic fuel runs out. The only thing left in the aftermath is a stellar mass black hole, a gravitational remnant of a once giant star's demise. Supermassive black holes are at the center of the majority, if not all, of large galaxies on a larger scale. These huge grandiose beasts, which have masses between 1 million and 1 billion times that of the Sun, are past our current understanding because of their monstrous size, areas of strength for and fascination. Even though their origins remain a source of wonder and ongoing investigation, their presence is evidence of the forces that shape the universe. Strange results from astronomy. Although it may appear to be straightforward, the formation of supermassive black holes is anything but straightforward. Astronomers like Stephen Finkel from the University of Texas in Austin have discovered these massive black holes, which have a mass that is more than 1 billion times that of the Sun and have existed for less than 1 billion years since the Big Bang. It is amazing how they managed to reach such size in such a short amount of time. In an effort to find a solution to this puzzle, researchers are looking at the universe's distant past, which dates back approximately 13.7 billion years. In any case, it's not straightforward. Residue can darken the light from such a long ways back, making the early dark openings unbelievably faint and testing to break down. It's like endeavoring to settle a question with just sections of the riddle. However, perhaps the most exciting aspect of astronomy is its capacity to uncover secrets over time while exploring previously uncharted territory. Singe's 1019. A clever finding. Sears 1019, a newly discovered black hole, can be found in a galaxy. As part of the Cosmic Evolution Early Release Science Survey, which examined galaxies in depth, this fascinating discovery was made. This project's objective is to test and validate research methods. The survey's data, which are located in Boötes and Ursa Major, two well-known constellations, have sparked a lot of excitement among astronomers. The information gathered by JWST's keen eye may shed light on the mass, chemical composition, and numerous other crucial characteristics that make this particular galaxy unique, shedding light on aspects of cosmic evolution that were previously unknown. Researchers can change how we see divine cycles and look into the beginnings of the universe through this examination. They additionally found two additional old supermassive dark openings, making this disclosure not the only one. Cosmologists have fundamentally progressed their comprehension because of the complete Soothsayer's review. By combining extensive spectral data with near and mid-infrared images from the satellite telescope, they have recently discovered black holes in galaxies like Sears 1019. Because of the telescope's astounding powers, stargazing research is moving from hypothesis to quantifiable reality. Because of its advanced technology, we are now able to observe and investigate these events in unprecedented depth. As light goes from faraway cosmic systems to Earth, it bit by bit becomes twisted, is extended into longer frequencies, and pushes toward the infrared locale of the range. Astute astronomers discovered the black hole in Sears 1019 by looking for bright galactic cores or active galactic nuclei, which are thought to be the first signs of black holes that eat a lot of matter and release a lot of energy. The discovery that JWST's initial observations revealed a large number of active black holes from the first billion years of the universe's history shocked scientists, who had long assumed that early black holes were uncommon. The Sears survey has proven to be priceless thanks to the JWST's highly sensitive infrared equipment's extraordinary potential. The one-of-a-kind person of these dim holes, as well as being staggeringly light, Diviners 1019 is striking for being an old article, as per a fascinating NASA official statement. With a mass of around 10 million Sun-based masses, this captivating dark opening is undeniably less gigantic than the enormous dark openings seen farther away by different observatories, which have masses more prominent than 1 billion times that of the Sun. To give some foundation, how about we analyze the dark opening known as Sagittarius A*, situated at the focal point of our own Smoothway world. It has a mass of around 4.3 multiple times that of our Sun. Even though it seems like a lot, this is much smaller than you'd expect from a modern supermassive black hole. Contrasted with the more enormous dark openings recently found, this new revelation isn't as splendid. The overview likewise uncovered two additional heavenly lightweights, supermassive dark openings with masses not exactly the run-of-the-mill perceptions at such distances. These objects were formed approximately 1.1 billion years and 1 billion years after the Big Bang, respectively, and are situated in the centers of the galaxies Sears 2782 and Sears 746. Sears 1019 also contains the core black hole. At around 10 million Sun-powered masses, every one of these dark openings steers the astronomical result. Be that as it may, what does a vast heavyweight resemble? For example, the enormous article at the center of the universe M87 is 6.5 billion Sun-oriented masses. In Sears 2782, no bothersome dust obscured James Webb's view of the black hole, making it simple to locate. In contrast, Sears 740 SIXS black hole presented a minor obstacle because it was partially obscured by dust from the bright accretion disk surrounding it, indicating that it might be in a star-forming galaxy. We now know more about a wide variety of black holes thanks to the Sears survey results, which have made them even more mysterious and intriguing. Scientists likewise made a captivating disclosure at the focal point of their perception: a supermassive dark opening, as proven by the indication of quickly moving plasma. Albeit this mark was fairly unassuming, the scientists' careful reproductions and examination permitted them to measure vulnerabilities, giving them a sure 95% confirmation that this astonishing element had been distinguished. The team is optimistic about the prospects for the future and anticipates that subsequent observations will lead to even more significant discoveries. New perspectives on black holes and the space around them will result from advancements in science and technology, which will only increase the significance of this signal. Results of the discovery. The implications of this finding are significant. Considering that Diviners 1019 showed up just a short time after the huge explosion, interesting thoughts regarding its beginning emerge. A long-held scientific theory that supermassive black holes formed when smaller ones merged is supported by this unexpected finding. Yet, there's an issue: the dark opening in Diviner's 1019 is gigantic. There are only two possible explanations for where it came from. The first scenario suggests that Sears 1019 may have emerged directly from the collapse of a massive gas cloud, long before galaxies took shape. These gas mists, 10,000 to 1 million times the mass of the Sun, were tracked down in these mists. Alternatively, the dark opening might have framed because of the breakdown of a star bunch. According to the second hypothesis, Sears 1019 seed black hole started out small but quickly grew as it ate a lot of matter in the area. Most of current dark opening speculations recommend that more modest dark openings should frame first in star bunches or worlds prior to converging to make the seeds of supermassive dark openings. However, our understanding of how black holes develop throughout the universe may be seriously challenged if the new findings continue to produce similar outcomes. We've just barely started to investigate the profundities of room. Such countless secrets are yet to be uncovered. The James Webb Space Telescope has proactively permitted us to propel our insight into the universe, and we anxiously guess what it will uncover straight away. The accompanying huge shock is not far off. Gratitude for watching. What do you believe is the source of these enormous black holes? If it's not too much trouble, share your considerations in the remark area. Make sure to subscribe to this video and give it a thumbs up. The following one will feature you.